Section 3.2 talks about areas of polygons and circles. And here it says students will be able to understand and explain how to find the areas of rectangles, parallelograms, triangles, kites, trapezoids, regular polygons, circles, and sectors of circles, doing some conversion of area units, and figuring out the ratio of areas of measures of similar figures. Okay, so here we have the formula for the area of a rectangle. And the formula is area is equal to the length times the width. Okay, so area is length times the width. And so the area in this case is going to be 4 times 3. And we're going to say 12, and we're going to say units squared. The reason why it's units squared, I want you to notice, if I start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and each of these are little squares, okay? So that's why we say square units. The area of a parallelogram is base times the height, okay? And so the area of a triangle is going to be 1/2 the base times the height. And the area of a trapezoid is going to be 1/2 the height times base 1 plus base 2. Okay, so let's see, it says for this first problem, let's find the area of triangle ABC in each of the following drawings. Okay, so first thing I'm going to do, I'm going to write down the formula of a triangle. It's 1/2 base times the height. So 1/2, the base in this case is 7 centimeters times the height, which is 6 centimeters. Okay. This is equal to 1/2, let's see, 6 times 7 I know is 42, this is centimeters squared, and then half of 42 is going to be 21 centimeters squared. So there's the height of that triangle. Now, let's see if we can find the height of this one. The formula is still the same, 1/2 the base times the height. Okay. So 1/2, the base in this case is 10 centimeters, times the height, which is 3 centimeters. Okay, so this is 1/2. 10 times 3 is going to give me 30 centimeters squared. And then the last part is, what is half of 30? 15 centimeters squared. The main thing to understand, y'all, is in dealing with area, whatever units you're dealing with, whether they're yards, feet, inches, meters, centimeters, they're always going to be square units, okay? It doesn't mean I'm not going to now take 21 and squared. I'm not going to do that. I'm not going to take 15 and squared. Just on the units itself, there should be centimeters squared, okay? And this is anytime we're dealing with area. So let's take a look. It says, find the area of each of the following quadrilaterals. Okay, so we have a square. So the formula for the area of a square is the side being squared. So we're going to take 3 centimeters and we're going to square it. That's going to give us 9 centimeters squared, right? So right here, I'm going to put 9. And then this part here, you're going to have a little drop-down menu. You want to make sure that you pick the one that says centimeters squared. It could say squared centimeters, but the idea is the same, okay? Part B, find the area of the rectangle to the right. Okay, so the formula for the area of a rectangle is the length times the width. So 20 centimeters times 5 centimeters is going to give me 100 centimeters squared. So again, I'm going to pick 100 and then again centimeters squared. Okay. All right. So let's take a look at the next one here. Area of a parallelogram. The formula for the area of a parallelogram is the base times the height. So the base, 6 centimeters, times the height, which is 5 centimeters, is going to give me 30 centimeters squared. So again, right here, oops, that doesn't look like a pretty 30, does it? 30 centimeters squared, okay? All right, and part D. Part D is in dog, says the area of a trapezoid. Okay, so let's figure out the area of a trapezoid. The formula is 1/2 the height times base 1 plus base 2. Okay. So 1/2. The height is 13. So I'm just going to do it like this, 13 centimeters. Base 1 plus base 2. So 18 plus 16. This is also in centimeters. Okay. So I'm going to have 1/2 times 13. 16 and 18 should give me a total of 34. Okay. And I'm just going to take my calculator. Let me move it this way. Let's turn it on. 13 times 34 is 442. So this is 1/2 of 442 centimeters squared. And half of 442 is 221 centimeters squared, right? So right here, I'm going to pick 221, and then again, centimeters squared. Okay. All right. So the next problem here says, can we find the cost of carpeting the following rectangular rooms? Okay, so we have a room that's in the shape of a rectangle. One side is 7.5 meters. The other side is 3.5 meters. So let's find the area. So the area is the length times the width. So I'm going to take 7.5 times 3.5. I'm going to use my calculator for this. So let me clear that out. There's just a lot of mess on there. 7.5 times 3.5. And so my area is 26.25 meters squared. Now we're trying to find the cost, okay? And it says the cost is $11.24 per square meter. Okay, so the way we're going to do the cost, total cost I should say, is I'm going to take my area, which is 26.25 meters squared, and I'm going to multiply it by $11.24 per square meter. Okay, you can think of this over 1 if you want to. Now again, I want you to notice before, meters squared on the top, meters squared on the bottom are going to cancel out. The only units that I have on the top are now in dollars. So 26.25 times $11.24, and we are coming up with $2.95 and a nickel. $295.05, right? Told y'all, what do you call a boy with no nickels? Nicolas. Quack quacks. I know it's a corny joke, but trying to make it go, guys. All right, let's take a look at part B. Part B is going to be the same way. Okay, so we're going to have a rectangle, and it's going to be 15 yards by 12 yards, right? So let's find our area. Length times width. So 15 times 12. Let's see what that is. 15 times 12 is 180. 180 square yards. Okay. The cost is $32 per square yard. Okay, so we're going to say the total cost is 180 square yards times, let's see, what did we say the cost was? $32 per square yard? $32 per square yard, right? So these square yards are going to cancel, and we're just going to multiply 180 times 32. So multiply it by 32, and we are coming up with $5,760. Come on, pen. $5,760. And there's our cost. Okay. All right. So the next problem we have here is asking us, can we find the area of the regular polygons? I bet you we can. I'm going to do part B first because part B is going to be easy breezy cover girl. So remember, the formula for the area of a triangle is 1/2 the base times the height. Okay. So this is going to be 1/2. The base is 4 centimeters times the height, which is 2 square root of 3 centimeters. Okay. So let's take a look here. 4 times 2 is going to give me 8 square root of 3 centimeters squared. Now we're going to do half of that. Well, half of 8 is just 4. Okay. So my answer is 4 square root of 3 centimeters squared. Okay, now let's see if we can do part B. So part B, I'm going to kind of zoom in here a little bit so you can see this a little bit better. And what I want to think about is, if I were to draw a line going from there to there, another line going from there to there, I'd have a triangle, right? And if I kept doing that, excuse me, from each of those vertices over here, I would have 1, 2, 3, 4, 5. I'd have 6 triangles. So if we find the area of one of them, then we can multiply that by 6, and we'll find the area of the whole figure. So remember what we said about the area of a triangle? We said it was 1/2 the base times the height. So this is going to be 1/2. The base in this case is 10 centimeters. The height is this number here, which is 5 square root of 3 centimeters. Okay. So let's see, this is going to be 1/2. 10 times 5 is 50 square root of 3 centimeters squared. And then half of 50 is going to be 25 square root of 3 centimeters squared. Now we just found the area of one of those. So now, if we want to find the area of the whole thing, we're going to take this number here and we're going to multiply it by 6. Okay, so 6 times 25, if you had 6 quarters, you should have $1.50 times the square root of 3 and then centimeters squared. Okay, so part A was a little bit more challenging in that I had to kind of examine what was really going on there. Okay, kind of take a closer look. Okay, so the area of a circle is right here. It's pi r squared. And so we're going to do this problem here, guys. There are 4 parts to it, so we're going to do it in pieces. And it's asking us to find the area of the following shaded regions. Okay, so let's do part A first. We're trying to find the area of the shaded region. Okay, so look, I'm going to do it like this. Let's find the area of the big circle, this big circle right here. Okay, so first thing I need to find out, what is my radius? The radius is going to go from the center all the way over here. Well, if this is 4, the whole radius from here to here would be 8. Okay, so my formula says pi r squared. So this is pi times 8 squared, 64 pi, since we're dealing with centimeters, centimeters squared. Okay, now let's see if we can find the area of the smaller circles, like those right there. Okay, so the area of the small circle is going to be, again, pi r squared. R in this case is 4, so pi times 4 squared, which is going to be equal to 16 pi centimeters squared. Now, if I want to find the area of just the shaded part, so let's do it like this. Area of the shaded, I'm going to take the big circle minus 2 of the small ones, right? So the big circle we said was 64 pi minus 2 of these, 2 times 16 pi. This is going to be 64 pi minus 32 pi, which is still 32 pi, again, still dealing with centimeters squared. And that's how we were able to do part A. Okay. Now, let's see if we can do part B. Okay, so part B. Let's see if we can find the area of this semicircle. Okay. So if the area of a circle is pi r squared, the area of a semicircle would be pi r squared over 2, because it's going to be half of it, right? Okay, So the area of the semicircle is going to be pi. R in this case is, so we're going to have 3 squared over 2. So this is going to be 9 pi over 2. We're still dealing with centimeters, so centimeter squared. Okay. Now, we know that this distance from here to here is 3, so this one here is also going to be 3, right? Centimeters. So we can find the area of that triangle. So the area of the triangle is going to be 1/2 the base times the height. So 1/2, let's see, the base in this case is the 3 times the height, which is the 6. So this is going to be 1/2 of 18 centimeters squared. So 9 centimeters squared. Now again, if we want to find the area of the shaded region, right, the green part, we're going to take these two numbers and we're going to add them together. So we're just going to say 9 pi over 2 plus 9 centimeters squared. Okay. Alrighty. Now I want you to take a look at part C. So part C, we're going to find the area of sort of like this yin-yang type symbol, right? So I want you to notice that isn't this white area right here really the same amount as that green area right there? So if we were to kind of fold this over and fill it in, it would just be this part right here. And I don't know if I have, there you go. And this part would kind of be white now, right? We really wouldn't have that right there. So we're really looking for the area of this kind of semicircle, right? Okay, let me do this in green so it looks a little bit better. And we're filling this in part here with green. So we know that that piece is 3. So wouldn't the whole piece here be 6? Okay. So for part C, let me get my marker in black again. Here we go. For part C, I'm looking for the area of a semicircle. And it's going to be pi r squared over 2, which will be pi times 6 squared over 2. So this is 36 pi over 2. And we end up with 18 pi. Again, we're still dealing with centimeters squared. Okay. All right. And now we're going to do part D. Okay. So part D, let's see if I have a little bit more room over here. Let's see if I can kind of copy this down. So part D, we have something that kind of looks like this. Okay. And we know that the total distance from here to here is 10. What I want to kind of do is look at a piece of that, okay? So I'm going to look at a piece of it like this, okay? And I know that from here to here is 5, and I know from there to there is 5, okay? And then from that same piece, what I want to kind of do is say, look, suppose this is what I had, right? Could I find the area of this piece here, and then could I also find, say, the area of that piece right there? So suppose I wanted to find the area of this kind of circle, chunk of a circle there, okay? So the area of my circle would be pi r squared over 4. It's 1/4 of a circle, right? So the area of my circle is going to be pi times r, our radius is 5, so 5 squared over 4. And let's see, the area of my circle is going to be 25 pi over 4. Okay. Now, if I wanted to find the area of the square, of this square right here, well, it's going to be the side squared, which is 5 squared. That would be 25. Okay, I'll deal with my units in a minute, okay? Now, let's see if we can find the area of, say, the white piece, this sort of region right here. Okay, if I wanted to find the area of that white region, I would take 25 minus 25 pi over 4. Okay. So, if I come back to the original sort of little segment that we had, and if I wanted to find the area of that piece right there, I would have to say it's going to be, so the area of this one right here is going to be the area of the square minus 2 times the area of the white pieces. So the area of the square was 25 minus 2 times that. So let me kind of move it here. 25 minus 25 pi over 4. So this is going to be 25 minus, let's see, 2 times 25 is 50. I'm going to multiply that by a negative 2. So a negative and a negative is going to be a positive. This 2 here will reduce with that 4 and give me a 2. That's a 25 pi over 2. Okay. And so that's now going to be equal to, these can combine, a negative 25 plus 25 pi over 2. So what we did is we found the area of one of these regions right here. Okay. And that area ended up being, let me write it down here for you all. I'm just going to rewrite it, guys, where the positive one comes first. So I'm just going to switch these two. 25 pi over 2 minus 25, okay? Now that was the area of one of those. Now we have 4 of them, so I got to take 4 times that. So if I multiply this guy here by 4, again, this 2 and that 4 will cancel. They'll give me a 2. So 2 times 25, give me a 50 pi. 4 times 25 will give me a 100. This is all going to be in parentheses. And if you notice, my units originally was in centimeters. So this is in centimeters squared. So that last one's kind of a bit of a doozy. But it just takes a little bit of time to be able to figure it out. Okay. All right. So let's see if this next problem is a little bit easier. Okay. We're going to do it in pieces. It says a circular flower bed is 24 meters in diameter. Okay, so first thing I'm going to do, I'm going to draw a circle. We know that the diameter here is 24. Oops, 24, not 25. And meters. Okay, it has a circular sidewalk around it, 1 meter wide. So now we have a little bit of a bigger circle. I know it's a little ugly, but I'm doing this freehand, 1 meter, right? Find the area of the sidewalk in square meters. So we're looking for the area of this border, okay? So we have 2 circles. We have the red circle. Let's find the area of the red circle. If the diameter here is 24, then the new diameter of the red circle would actually be 25. So the radius would be 25 over 2, okay? 25 over 2 is the same thing as 12 and a half. So I'm going to take 12.5 squared times pi. Okay. I'm going to do this on my calculator. Let me turn it on. So 12.5 squared is 156.25. So 156.25 pi. Okay. Now let's find the area of the black circle. So the area of the black circle, if the diameter here is 24, then the radius is 12. So it's going to be 12 squared times pi. This is going to be 144 pi. And then now all we got to do is subtract them. So I'm going to take 156.25 pi minus 144 pi, and we'll find the area of that sidewalk. So minus 144. So we have 12.25 pi meters squared. The reason why meters is because our units is given to us in meters. Okay. Alrighty. So the next problem that I have here says, if the area of a square is 400 centimeters squared, what is the perimeter? Okay, so here is my square. Okay, we know the area is 400 centimeters squared. So remember, the formula for the area of a square is the side squared. So if the side squared is 400, what I need to do to find the side is we take what we call the square root on both sides. So I'm going to take my calculator, I'm going to clear this out, okay? I want to get to my square root. I want you to notice right above the x squared button is my square root button. So I'm going to hit second and square root, right? So I hit second and then the x squared button, 400, to close that off. And so my side is 20, okay? So that means that the sides here are 20, 20, 20, and 20. So in part A, we're asked to find the perimeter. Perimeter just means, can we add them all up? Well, if we have 20 4 times, that would be 80 centimeters. Not squared, I'm sorry, not squared, just 20 centimeters. That would be my perimeter, okay? Now look at part B. Part B says, if the perimeter of a square is 92 centimeters, what is the area? Okay, so here's my square. And I know that my perimeter is 92 centimeters. That means when I add up all the sides, I get 92. So if I take 4 times the side, that's going to give me 92. So when I divide both sides by 4, let me get my calculator, what's 92 divided by 4? I'm going to come up with 23 centimeters. So that just means that each side here is 23, 23, 23, 23. Now we're trying to find the area. So the area says take that side and square it. So if I take my calculator and say, what's 23 squared? I'm coming up with 529 centimeters squared. Okay. Alrighty. So the next problem here says, can we find the area of the shaded staircase in the drawing? All right, so let's get a couple of things, see if we can figure out. The distance from here to here is B. Well, the distance from each of those is also going to be B, right? We know the height of the whole thing is H. So wouldn't the height of each of them be H over 4? And so if I wanted to find the area of one of those blue triangles, remember my formula is 1/2 the base times the height. So 1/2 the base, we're calling it B. The height, we're calling it H over 4. Okay. So B times H is just BH, can't do much with that. But this 2 is on the denominator, and so is that 4 on the denominator, and that's going to give me 8. And whatever units we're dealing with, we would say units squared. That's given me the area of just one of those triangles. How many of those triangles do we have? Well, we now have 4 of them. So I'm going to take 4 times the base times the height over 8. Think of this 4 as 4 over 1. Now, this 4 will reduce with that 8 and give me a 2. So we have base times height over 2. Again, units squared. Okay. All right. So now we're going to talk a little bit about converting English units of area. So one square foot is the same thing as 1/9 of a square yard, or 144 inches squared. 1 square yard is 9 square feet, or 1,296 inches squared. 1 mile squared is the same thing as 3,097,600 yards squared, or 27,878,400 feet squared. Sorry. Okay, so let's see if we can do some conversions. So I'm looking at part A down here. So we have 72 feet squared, okay? And we want to convert that into yard squared, okay? So feet squared into yard squared, okay? So we know, when I think of this over 1, I know that 1 square foot is the same thing as 1/9 of a yard. Of a square yard, I should say. Okay. So like we said earlier, these units of feet are going to cancel. I'm multiplying 72 times 1/9. Okay, so how do you do that? You go like this: 72 times, open up your parentheses, 1 divided by 9, close them off, hit enter, and we come up with 8. So there it is, 8 squared yards. So this one here is going to be 8. All right, now let's take a look at part B. It says 10 to the 4th yard squared, and we want to convert that into feet squared. Okay, so 10 to the 4th, just so you get an idea, 10, raise it, this little up arrow right above my division sign, to the 4th should give me 10,000. Okay, so let's write it out like this. 10,000 yards squared, and we're going to convert that into feet squared. Okay, so right here, yard squared to feet squared. So I know that 1 squared yard is the same thing as 9 square feet. So again, these units here are going to cancel, and I'm just going to multiply. So 10,000 times 9, 90,000, right? So my answer for this one is 90,000 square feet. Okay. All right, let's do part C. We have 5.5 miles squared, and we're going to convert that into acres. Okay, so right here we have some information about miles and acres. So I know that 1 square mile is the same thing as 640 acres. So mile squared and mile squared are going to cancel, and again I'm just going to multiply. So 5.5 times 640 is 3,520 acres. 3,520. So that's this one right here. And then, let's see, we want to go from acres to yards. So here's our conversion from acres into yards. Okay, so let's say 4 acres times something is going to give me my answer in yards squared. Okay, so 1 acre is the same thing as 4,840 square yards. Okay, so again, my units of acres are going to cancel, and I'm just going to multiply again. We move this guy over this way. So 4 times 4,840, and I'm coming up with 19,360. 19,360. So right here, again, same thing, 19,360. All right. So these little conversions definitely help a whole lot because they're telling me exactly how to do my problems, right? Okay. So it says a glass coffee tabletop is essentially a square, but it has rounded circular corners as shown. Find the perimeter. Okay, so remember what the perimeter means. Perimeter means the distance all the way around. So here, 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 plus those 4 corners. Okay? So let's see if we can do the easy part first, the square. Now, the one thing I want you to notice, these are in feet, and this part is in inches. So let's convert the feet into inches. So remember, 3 feet, if I'm going to convert it into inches, and this is 3 over 1 times 1 foot. It's the same thing as 12 inches. So 3 times 12 is 36 inches. So this is 36 inches, 36 inches, 36 inches, 36 inches. Okay, so to find the perimeter, we're going to take 36 and we're going to multiply it by 4. So what's 36 times 4? Oops, 36 times 4 is 144 inches. Okay. And then we have these 4 sort of corners here, right? Oops, trying to get my eraser. There we go. We got these 4 corners, okay? And those 4 corners represent, if you put them all together, you get a circle, right? Because you got a quarter of a circle here, quarter of a circle here, 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 and here. So remember, this is what we call the circumference of the circle. So the circumference is going to be 2 pi r, okay? So in this case, we're going to have 2 pi times my radius, which is 5. So that's going to be 10 pi. Again, this is in inches. So now the total perimeter is going to be these two added together. So 10 pi plus 144. I'm going to put all this in parentheses because they're all in inches. Okay? They're all in inches. All right. So arc length. We talked a little bit about arc length in 13.1, but I just wanted to give you all the formula again. And it's right here. And it says, if a 30-degree sector of a circle has a radius of 18 centimeters, what is the perimeter of the sector? So remember what they're asking me to find here. They're asking me to find this entire distance. Okay? So let's first find the length. So the length is going to be pi times the radius, which they told us was 18 centimeters, times our angle, which was 30 degrees, all over 180. Okay. And so let me see if we can do some of this stuff on our calculator. Scooch this guy this way. So I'm going to take 18 times 30, and that's giving me 540 pi over 180. And I think we can divide 540 by 180, actually. Yes. So the length is 3 pi. This is in centimeters. Okay. That's just the length of that arc. That's just this part. Oops. That's just this part right here. But we want to find the whole perimeter. So if I know that the radius is 18, then this piece is 18 also. So I'm going to have 3 pi. 18 and another 18 is going to give me 36. And this is going to be in centimeters. Its length, we're just measuring a distance. So single distances like that will be like centimeters or feet or whatever. The only time we're going to square it is when we're dealing with area. Okay, so it says, explain how to use geometric shapes to find an equivalent expression not involving parentheses for a plus b times c plus d. Okay, so let's see what we're going to do here. We're trying to find, if you look at this formula here, a plus b times c plus d. So they're saying, can we take this distance times that distance? So we're finding area. So I already know that choice A is not what I'm looking for because it talks about perimeter. Okay, and then so we're trying to find the area of the entire picture because we're finding the area using this side here and this side here. So it says find the area of each smaller rectangle. Well, that's good, but notice all three of them have it, so that's good. And then if we're trying to find the area of the whole thing, so once we find the area of this one, this one, this one, and this one, wouldn't we now have to add the areas? Yes. So for this particular problem, C is the answer that I am looking for. And that should be 13.2.